I was a software development engineer on the checkout team at a UK online marketplace. My team owned the service that calculated delivery promises before a customer placed an order. Our direct customers were shoppers relying on those dates, and the fulfillment teams that planned work from the same promise. We were preparing a change to support split shipments. 2 days before the release deadline, our regression suite showed that about 0.7% of baskets could display a delivery date 1 day earlier than the warehouse could achieve. It only happened when items came from 2 fulfillment centers and 1 crossed a bank holiday boundary. The product manager argued that we should launch because the affected volume was small, the commercial campaign was already booked, and the checkout still completed. The proposed workaround was to monitor complaints and fix the calculation in the following sprint. I refused to sign off the release in that form. The percentage sounded small, but at our expected campaign volume it meant roughly 1,400 customers a day receiving a promise we already knew could be wrong. I also felt monitoring complaints was the wrong control because we would only learn after customers had been disappointed. My objective was to preserve the campaign date without knowingly publishing an inaccurate promise. I set 2 conditions: either reduce the affected path to 0 in our test matrix, or prevent split shipment baskets from using the new calculation until it was safe. I also wanted evidence that the fallback itself would not create a new availability problem. First, I reproduced the defect against production-shaped basket data and traced it to the service, normalizing both fulfillment center calendars into the shopper's time zone before selecting the later date. That ordering was incorrect around regional holidays. I considered 3 options. We could delay the whole release, patch the calendar algorithm immediately, or isolate the unsafe path behind the existing feature flag. A full delay protected quality but lost the campaign. A rushed algorithm change touched shared date logic and created more risk than I could validate in 2 days. I recommended the feature flag option because it preserved the known good calculation for affected baskets while allowing the rest of the launch. The difficult part was that the flag only existed at account level, not basket level. I built a narrow eligibility check using data the checkout service already held: number of fulfillment centers, destination region, and whether either shipment crossed a holiday boundary. I kept the rule deliberately conservative. If any input was missing, it selected the old calculation. I also defined the launch guardrail before asking for approval. We sampled displayed promises against warehouse calendars, and any early promise or mismatch rate above 0.05% would disable the new path. The duty engineer could see the affected basket and fallback reason without inspecting customer data. The product manager still worried that the fallback would reduce the benefit of the launch. So I ran the previous 4 weeks of baskets through both paths. The model showed that about 96% of orders would receive the new split shipment promise, while the risky 4% would retain the existing, slightly wider window. That evidence gave us a customer-based trade-off rather than an argument about engineering preference. During final testing, I found our original test set covered UK bank holidays but not regional holidays in Scotland and Northern Ireland. I added those calendars, plus leap day and daylight saving boundaries, and made the cases mandatory in the deployment gate. One new test exposed a second issue in cache expiry, so I fixed that before launch rather than accepting it as unrelated scope. We released on the campaign date with the conservative fallback. There were no confirmed early delivery promises from the new path during the first month. 96% of eligible baskets received the more precise date, and delivery-related contacts for split shipments fell by about 11% compared with the previous month. 3 weeks later, after a properly reviewed algorithm fix, we removed the fallback and reached full coverage. The thing I took away was that a quality standard is strongest when I can translate it into customer exposure and a safe release mechanism. Since then, when I block a launch, I bring both the quantified risk and the smallest reversible path that protects the customer.